video, we want to find the p-value in a two-tailed test. So a p-value is an area, and in a two-tailed test, it is the area to either the left or the right of the test statistic, depending on the value of your test statistic, and then that value doubled because we have a two-tailed test. For this example, we're going to find the p-value in a two-tailed test if the test statistic is z is equal to 1.23. So in this case, z is a positive value. I'm going to just put a quick picture here of what's going on. So I have a normal distribution here. Right down the middle is z is equal to 0. The value of the test statistic is z is equal to 1.23. So that's a positive value. So that's to the right of z is equal to 0. Negative values are to the left of z is equal to 0. So we have somewhere right here, z is equal to 1.23. Down here would be a negative value. Z is equal to negative 1.23. So it's a two-tailed test, and the test statistic is a positive value. So since it's a two-tailed test, what I want to do is I want to find this area in this upper right tail and then double that. So I want to use technology, and I want to use a function on the calculator called normal CDF. And we have technology videos that accompany these videos on each of the topics. So I want to use normal CDF, and I'm looking for this area here. That'll be the p-value. So I'm going to start at 1.23, and I'm going to go up to positive infinity. So the way I may represent that is a bunch of nines. Maybe I'll put in like 6 nines. Just put in some very large number there. So normal CDF, and that will give you your p-value. And that will be in just this upper right tail here. So if we do that, we get that our p-value is approximately 0.1093. Okay, and that value actually goes on for quite a long time. So approximately 0.1093. So we have a two-tailed test here. So since we have a two-tailed test, we want to take this value here, this p-value, which we found to be 0.1093, and double it. So double the value of 0.1093, and if we do that, we're going to get a p-value of approximately 0.2187. So I didn't round when I was calculating this value here. I waited until I doubled it to round here. So using technology in a two-tailed test, finding the p-value, if the test statistic is z is equal to 1.23, that value is approximately 0.2187.